All right. So today's lesson is kind of what we've been building up to this week. So it's on graphing systems of linear inequalities. Before we went on break, we were learning about graphing systems of linear equations. Okay, the difference between an equation and an inequality is the symbol. Equations have equal signs. Inequalities have inequality symbols. And so when you graph them, they look different as well. An equation that is graphed, a linear equation, is just a straight line in the coordinate plane, whereas a linear inequality graphed in the coordinate plane is either a solid line or a dashed line, and then we shade on either above it or below it. So when we look at graphing systems of linear inequalities, we're going to be graphing two inequalities. So we're going to have two lines. They could be solid, they could be dashed, and we're going to have two sets of shading, and we're going to see where they shade and like maybe somewhere will overlap. Okay? This lesson goes with your textbook lesson 12.2. And your EQ is how do you solve a system of linear inequalities? Right? We're looking at the method of graphing to solve them. And your learning goal is that I can graph the solution set to a system of linear inequalities in two variables as the intersection of the corresponding half planes. All right, and so we've seen that before. When you graph a single linear inequality, you do get a half plane that shows up. And so we're going to look at two half planes because we'll have two inequalities and see where they intersect. So I'm going to start by showing you a video.
Graph the solution set for this system. And it's a system of inequalities. We have y is greater than x minus 8, and y is less than 5 minus x. So let's graph the solution set for each of these inequalities. And then essentially where they overlap is the solution set for the system, the set of numbers or the set of coordinates that satisfy both. So let me draw a coordinate axis here. So that is my x-axis. And then I have my y-axis. And that is my y-axis. And now let me draw the boundary line, the boundary for this first inequality. So the boundary line is going to look like y is equal to x minus 8. But it's not going to include it because it's only greater than x minus 8. But let's just graph x minus 8. So the y-intercept here is negative 8. When x is 0, y is going to be negative 8. So we just go negative 1, negative 2, 3, 4, 5, 6, 7, 8. So that is negative 8. So the point 0, negative 8 is on the line. And then it has a slope of 1. This is you don't see it right there, but I could write it as 1x. So the slope here is going to be 1. I could just draw a line that goes straight up. Or you could even say that it'll intersect if y is equal to 0. If y were equal to 0, x would be equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. And so this is x is equal to 8. But it has a slope of 1. For every time you move to the right 1, you're going to move up 1. So the line is going to look something like this. And actually, let me not draw it as a solid line. If I did it as a solid line, that would actually be this equation right here. But we're not going to include that line. We care about the y values that are greater than that line. So what we want to do is do a dotted line to show that that's just the boundary, that we're not including that. We're not including that in our solution set. Let me do this in a new color. So this will be the color for that line, or for that inequality, I should say. So that is the boundary line. And this says y is greater than x minus 8. So you pick an x, and then x minus 8 would get us on the boundary line, and then y is greater than that. So it's all the y values above the line for any given x. So it'll be this region above the line right over here. And if that confuses you, I mean, in general, I like to just think, oh, greater than is going to be above the line. If it's less than, it's going to be below a line. But if you want to make sure, you can just test on either side of this line. So you could try the point 0, 0, which should be in our solution set. And if you say 0 is greater than 0 minus 8, or 0 is greater than negative 8, that works. So this definitely should be part of the solution set. And then you could try something out here like 10 comma 0 and see that it doesn't work. Because you would have 10 minus 8, which would be 2, and then you'd have 0, and 0 is not greater than 2. So when you test something out here, you also see that it won't work. But in general, I like to just say, hey, look, this is the boundary line, and we're greater than the boundary line for any given x. Now let's do this one over here. Let's do this one. The boundary line for it is going to be y is equal to 5 minus x. So the boundary line is y is equal to 5 minus x. So once again, if x is equal to 0, y is 5. So 1, 2, 3, 4, 5. And then it has a slope of negative 1. We could write this as y is equal to negative 1x plus 5. That's a little bit more traditional. So once again, y-intercept at 5. It has a slope of negative 1. Or another way to think about it, when y is 0, x will be equal to 5. So 1, 2, 3, 4, 5. So every time we move to the right one, we go down 1 because we have a negative 1 slope. So it will look like this. And once again, I want to do a dotted line. I want to do a dotted line because we are, so that is our dotted line. And I'm doing a dotted line because it says y is less than 5 minus x. If it was y is equal to 5 minus x, I would have included the line. If it was y is less than or equal to 5 minus x, I also would have made this line solid. But it's only less than. So for any x value, this is what 5 minus x. 5 minus x will sit on that boundary line. But we care about the y values that are less than that. So we want everything that is below the line. And once again, you can test on either side of the line. 0, 0 should work for this second inequality right here. 0 is indeed less than 5 minus 0. 0 is less than 5. And then you could try something like 0, 10 and see that it doesn't work. Because if you had 10 is less than 5 minus 0, that doesn't work. So it is everything below the line like that. And like we said, the solution set for this system, are all of the x's and y's, all of the coordinates that satisfy both of them. So all the shaded in purple satisfies the second inequality. All the shaded in green satisfies the first inequality. So the stuff that satisfies both of them is their overlap. So it's all of this region in blue. Hopefully this isn't making it too messy. All of this region in blue where the two overlap, below the magenta dotted line on the left-hand side, and above the green magenta line. That's only where they overlap. So it's only this region over here, and you're not including the boundary lines.
All right, so that was an introduction of what it looks like when you graph a system of inequalities. And so basically, just to summarize what you saw in the video, the way you would do that when you need to graph a system of linear equalities is first, you would graph and shade the solution to the first inequality. And this is an example of that. So if my first inequality in my system is y is greater than or equal to negative 2x plus 2, remember that you think about it as being in slope-intercept form. And so you take the 2, and that tells you where to start. And then you take the slope of negative 2, and that tells you to rise 2 units and go 1 to the left so that you have a slope going down. And then you look at the symbol to recognize that it's a solid line because it includes that or equal to part. And because it's y is greater than or equal to, we shade above the line. So we shade everywhere. This is a half-plane solution. Second, you would then graph and shade the solution to the other inequality that you're given. So y is less than 5/10 x minus 1. We're going to graph this. It's in slope-intercept form. So we're going to take this negative 1 and start our graph on the y-axis there. And then we use our slope. 0.5 is the same as 1/2. That's the same as 1/2. So if I rise 1 unit and run 2 units, that's where I get my next point. I can repeat it to get the other points. And then this is my line. Now, I have to then look at the symbol. This is an inequality symbol, less than. Less than means we have a dashed line. Okay, so it's not solid, it's dashed. Because it's y is less than, that means I shade everywhere where y is less than the line, which is below. Okay, the numbers are smaller. We shade everywhere down here. So you have 2 half planes shaded, and third step here is you can see there is an overlapped shaded region. Okay, this overlapped area here. This is the solution to the system. Everything in this area, all the points, represent the solution to the system. Okay, so there's not one point that represents the solution. There's an infinite amount of points that represent the solution. Any point in this area. So, for example, the ordered pair 4, 0 is the solution to the system. The ordered pair 5, -3 is the solution to the system. The ordered pair 2, -1 is the solution to the system. Okay, we can choose points that are on this line because it's solid. We cannot choose points that are on this line because it's dashed. We have to choose something slightly below it. So here's your first interactive slide. Remember, some of you came in a little bit late. If you don't participate in the pair deck, that's going to get marked as non-responsive in Aries. So you need to make sure you're participating in the pair deck in the slides. You need to have the pair deck tab open along with our Google Meet. And so right now what you're going to do is look at this picture. We have a system of inequalities that has been graphed. The first inequality is y is greater than -3x plus 5. That's the blue dashed line. Okay, notice that it's right here at 5. That's the y-intercept, and then we're using the slope of -3. So I could think of that as going down 3 units into the right one. And then because of the symbol, it's dashed, right? We shade everything on this side because y is greater than. So if you look at where the line is touching the y-axis, we're at 5. So where's y greater than 5? Up. Okay, all the numbers that are up. So it's everything over here. And then our other inequality, y is less than or equal to x minus 2. So this again is in slope-intercept form, starting with the y-intercept of -2. That's why the line is crossing here at the y-axis at -2. And then our slope is the coefficient in front of the x term. We don't see it, but there is a 1 there. So my slope is +1, up 1 to the right 1, up 1 to the right 1. That's this red line. It is solid because the inequality symbol includes the or equal to part. Here it was dashed because there was no or equal to part. So when you include the or equal to part, it's solid. And then we're shading, where's y less than the line? So the line is crossing at -2, so where are the y values less than -2? That's this side, so we shade everything over here. All right, so this is what it looks like graphed, and what you're doing on this slide is you're going to drag the star to a location that shows the solution. Now I showed you on the last example, there are an infinite amount of ordered pairs that represent the solution to a graphed system of linear inequalities. So there are lots of possible choices to drag your star to. Now, just because there's an infinite amount does not mean everything works. There's only a certain area that would show you where the solutions are. So which area should you drag your star? Is it in the white? Is it in the blue? Is it in the purple? Is it in the red? I have 20 people in Pear Deck. I have 12 responses. Again, if you do not respond to these slides, you will not get your attendance credit. All right, you need to participate. Don't be afraid of making a mistake. Your name doesn't show up when I show responses. Okay, just try it. We're up to 14 out of 21 responses. Okay, so this is interesting. I'm noticing you guys are doing something that I taught you when we solved a system of linear equations. Okay, when we solved the system of linear equations through graphing, we knew the point of intersection where those two lines met. That was the one solution. Okay, now in this case, because the star is kind of big, I need the entire star to be contained within the solution area. So when you graph a system of linear inequalities, I'm going to go back real quick. Look here. Look at this example. The solution to the system is this dark green shaded area. Okay? Just the dark green shaded area. Everything in that area is the solution. The point of intersection here doesn't actually work because one of these lines is dashed. Now, I could get right up to it, and that's a solution, but I cannot include the actual point of intersection. So you're going to want to move your star to be completely contained in the purple overlapped area. Because for it to be a solution, an ordered pair to be a solution to both systems, it has to satisfy both systems. It has to be true for the blue, has to be true for the red. And the only where that it's true for both is where it's overlapping and it's showing as purple. So anywhere in this purple area is where you would find the solution to the system. All the ordered pairs here. Some of you still need to move your star over to the purple. I'm going to move forward and you're going to be able to come back and do that. Okay. So this next slide here, it's going to have you're going to go to your Pear Deck tab. All right. And you're going to be able to see that you have Desmos open. All right. And so I'm giving you a task to do right now. I want you to type in both inequalities in Desmos. Okay, so you're going to need to go to your Pear Deck tab, and you have a split screen. You have the Desmos graphing calculator on the right, and you have this slide on the left. So you're going to type in y is greater than negative x minus 2, and you're going to type in y is less than negative 5x plus 2. So you have to have two separate lines for both inequalities. And when you do that, what you're looking at is you're going to see you have a red half plane and a blue half plane. And there's one specific area where the two half planes overlap, okay? And that whole like double shaded area, that is going to be the solution to your system. So I could show you real quick. I'm showing Quaylon's screen right now. So Quaylon, you have to stay on the Pear Deck tab. But Quaylon did this, and he did it correctly. He has the red plane and the blue plane, and they overlap to create this triangular area. Anything in this area is a solution to the system. Anything outside of the area is not a solution to the system. Good job, Quaylon. Okay, Jordan, you got it. Brian, you got it. You did good. Oh yeah, you could kind of, it's starting to do that weird mirroring effect. It kind of creeps me out. Okay, I'm gonna come back to that so you don't see that. It just keeps reflecting the image. Brian, you got it. Jordan got it. Oh, some of you guys are coming back, but a lot of you did figure it out. Okay, so you can use Desmos to graph systems of linear inequalities. It's really useful for that. And we're gonna move on to slide 6. Okay, says you can determine if a point is a solution to a system of linear inequalities by checking if it lies within the shaded area of the graph system. We are going to use Desmos, the graphing calculator, to do this. So the question we're given says, which point would be a solution to the system of linear inequalities shown below? So our system is y is greater than or equal to negative x minus 4. And y is less than 2x minus 2. So what I'm going to do, and I'll do this with you, is I'm going to open up the graphing calculator on a tab. And if you want to quickly open that, it's desmos.com/calculator. I will put it in our chat right here. So paste There's the link to the Desmos graphing calculator, so you can open it up on another tab if you would like to. And what we're going to do is we're going to type in both of these inequalities. All right, so first one, y is greater than or equal to. Now, when you're typing into Desmos and you want to use that symbol, it's not on your keyboard, but it is on this keyboard down here. So you can show the key, let's say keyboard, keypad, they call it a keypad, okay? And then all those symbols that you may need pop up. So we want the greater than or equal to, which is right here. And then the rest of the inequality is negative x minus 4. All right, so as soon as I type that in, it graphs it. It graphs the line, it's solid because of the symbol, and it's shaded above because of the symbol. So the line choice and the shading side is all because of the inequality symbol. And then our second equation that we're going to type in is y is less than, and you can use the keypad or the keyboard for that. That's up to you. Y is less than 2x minus 2. All right. And so by doing that, I now see, I can zoom out a little bit. Anywhere that's purple, any point in the purple is a solution to the system. Any point in the red or the white or the blue only is not a solution to the system. The only place I can find solutions is in the overlap. So I have to find a point that is in this purple area. Now, if I look at the question that I have, my choices are negative 1, 4, negative 4, negative 7, negative 10, 3, 9, 9. So using this picture, you need to decide which of those points would fall into the purple area. And that's what you're going to do right now. Okay, so I already have 14 of you that have responded. So you're just going to kind of go through each of those ordered pairs and find the one that does work. And there should only be, let's see, there is only one point that works. Just double checking that that's true. If it's in the red only, the blue only, or the white, it is not a solution. It has to be in the purple. What point is in the purple? I have 15 responses out of 22. Let's see what you came up with. All right. Well, we have stars everywhere. Go through these points. And here's the thing that you could do with Desmos as well. I'm going to type in these ordered pairs. Negative 1, comma 4. Okay, it is now graphed. It is green. It is in the red. It is only in the red and not in the blue. This is not a solution. It is not negative 1, 4. Next point, negative 10, 3. Negative 10, comma 3. Purple point is in the white. Not only is it not in the red and not in the blue, it's not in either one of them. This is not a solution. We're getting closer to the answer, guys. Well, no. Negative 4, negative 7. Where is that at? We're going to add that point now. Negative 4, comma negative 7. Do you remember how to graph points? You always start at the origin, and the x coordinate tells you how far to go left or right. So negative 4 means I go to the left to negative 4. And then negative 7 tells me to go down to negative 7. This point is also in the white. We're down to one possibility. We only have one possible choice left. Is it 9, 9? I hope so, because I'm out of choices. And there you go. There's our red point. It is in the purple. That is the solution. The correct answer to that slide is the point 9, 9. So your star should be on 9, 9. All right. Now this question that we just did, came from Delta Math. So the assignment that you have today in Delta Math is exactly this. You do not have to go in and plot all the points like I just did, but if you are not sure where the point actually is, you can definitely show it this way. All right, so I'm going to come back here. There's still some of you that haven't moved your star. It should be on 9, 9. And we are on slide 7. So we are almost done. There's 7 of 8 slides. This is the last interactive one. It's a drawing slide. Do you think it is possible for there to be no solutions to a system of linear inequalities? If you think that's possible, what do you think it would look like? If you don't think that's possible, you think there's always going to be a solution, why? Why can there not ever be no solutions? What do you think? What would that look like? So this is a drawing slide. So I'm going to give you a few minutes to do that. So I see some of you are typing. You could type what you might think is true. You could draw a picture. Let's kind of take a look at, I'm going to give you a little more time. Because a lot of you guys look like you're in mid-thought. Remember, guys, I have 14 out of 22 of you have done this. You need to put something down, okay? Because if you're not putting anything down, I'm assuming that you just went to sleep. You joined the meet, and then you took a nap. And that's going to get reflected in Aries, that you were non-responsive. You have to participate, or you're not really in class. Let's see what we're coming up with here. Yes. Okay. There's always going to be a solution because you will never get the answer right. Yes, because I don't know. No. For my opinion, I think there is always a solution because for every problem, there's a solution. Yes, because... Yes, I think it's possible for there to be no solution. So this person is doing what I asked. They gave me their opinion, and then they are drawing what that would look like. Oh, I like it. Look at that. That's exactly what I was looking for. Nice work. Let's see. Yes, because sometimes it can have no solution. Parallel lines. Yeah. Or infinite solutions. Yes, because there's a dot. I'm not sure, to be honest. Okay. I think that there's going to be a solution because that's a picture of something. is probably possible, but it's also probably super rare because there's usually a solution in everything. I like that answer. Yes, because there's always possible. I don't know, honestly. All right, so you guys gave me some honest stuff here. Let me show you that sometimes a system of linear inequalities can have no solution. Okay, this happens when the boundary lines are parallel. Okay, so a couple of you kind of figured that out, and that's fantastic. So if they're parallel, now if they're parallel, just because they're parallel lines doesn't mean there's no solutions, but depending on what side you're shading on. Because if they were two parallel lines and you shaded this one this way and then you shaded this one this way, there would be a big section of overlap. Okay, but if you have something like this where you have two parallel lines and they're shading away from each other, they're parallel. They're never going to cross. You're never going to have any overlap to have any solutions. Okay, that is the end of that lesson. I am going to stop the recording on that.